Hey everybody, today we're going to continue to work with square roots and cube roots, but the difference today is that we will be looking to estimate them because what is under that radical symbol will not be a perfect square or a perfect cube. We're not going to use calculators one more time here. You can have that reference sheet with your perfect squares, your perfect cubes, and if you like the multiplication chart with the perfect square trail. That's what we're going to be using to refer to when we need to make our decisions. So I just want to start by just going over this problem on page 81 to just give you a feeling of where we would use what we're doing today. So there is a legend that states that while Sir Isaac Newton was sitting under his apple tree one day, an apple hit him on the head, and that's how he started to talk about gravity. So let's just say that the apple was 25 feet above his head. There's a little formula here, right here. The H stands for the height of the object from the ground, and the T stands for the time in seconds that it will take an object to fall from that height. And what we want to do is figure out, what happens if the apple is 25 feet above Sir Isaac Newton's head, basically. So the first thing, what is the square root of 25? What number times itself, what perfect pair of twins there multiplied to give you 25? Again, you can use your reference sheet. We're going to see it again in a second, but the square root of 25 is 5. Remember, we don't divide by 2. It's what number times itself equals the 25. It's the opposite of taking the exponent of a power of 2. So now if we want to figure out the time, we can replace the h, right, with that 25. And the square root of 25, we just said, would be 5. So the time it takes to fall would be 5 divided by 4. The square root of 25 divided by 4. And 5 divided by 4 is 1.25 seconds. It's 1 1/4 seconds. That's how long the apple would take to fall. But not everything grows at a perfect square distance from the ground. So what if the apple was 13 feet and we substituted the 13 in for the h? Now you can see the problem that this is not a perfect square. So we're going to have to do what's called estimate. Now I'm just going to give you a clue right now. Square root of 13 is about 4. I'm going to show you why in a second. And 4 divided by 4 would give you 1 second. So you cannot write the square root of 13 without the radical sign easily because it's not a perfect square. So we're going to have to estimate. If you did put this in the calculator, you would have a number that looks like pi. It's irrational. It goes on and on forever as a decimal, never repeats, never terminates. So we're going to have to estimate. So here's another example. You know that the square root of 8 is not going to be a whole number. You're not going to have a nice number because 8 is not a perfect square. So what we need to do is figure out what two perfect squares does 8 fit in between. So I'm going to bring your attention back to the perfect square trail. Now we're just looking at the highlighted diagonal that runs down here, and here are our perfect squares. So you'll notice that 8 isn't on there, but 8 does sit in between 4 and 9. So 4 and 9 are going to be our boundaries, our limits. So do you see the square root of 4 is going to be here, and the square root of 9 is going to be there, and the square root of 8 is in between them. Now the square root of 4 we know to be 2, and the square root of 9 is 3. And again, just to remind you, you take the square root of 9 and come up, there's the 3. The square root of 4 is 2. And oh, by the way, you might prefer to come out this way. It doesn't matter. So the square root of 8 has to be in between 2 and 3. Now the question is, who is he closer to? Well, look, between 4 and 8, there are 4 numbers. 8 minus 4, there's 4 different, right, places to grow here, where between 8 and 9, there's only 1. So it's closer to this guy. So if I was going to estimate the square root of 8 to a whole number, I'd say it's about 3. So if we go back to that Sir Isaac Newton there, remember the square root of 13 is going to be in between 9 and 16. And it's a bit closer to 16. It's only 3 away here, but it would be 4 away there. So that's where I got the 4 when I said that the square root of 13 is about 4. So you're looking for the borders. Where does it go in between, and which one is it closer to? Let's do some more. So let's say we were looking for the square root of 83. Now I'm going to come back to our square root trail and look right here. There's 81. There's 100. The 83 is in between. Is everybody with me? So the square root of 83 has to be bigger than 9, but smaller than 10. It's not going to be 8. It's not going to be 11. It's somewhere in between 9 and 10. Let me show you on the number line they provided on page 82. So there's the square root of 81. And there's the square root of 100. There's the 9 and the 10. And 83 minus 81, there's only 2 numbers here. But 100 minus 83, there's 17. There's a space of 17 here, only 2 here. He's slightly bigger than 9. So if we said which integer, now integer is just a whole number and its opposite. So we're not talking about decimals. We're not talking about fractions. So this guy is closest to 9. And that's how we estimate square roots. So I'm going to give you a chance to give it a go. I'm going to ask you to pause the video and try A, B, and C. Please realize that you can back up to that perfect square trail, and it's also on Classroom as a reference document, so you can refer to it there as you need to. Come back when you're ready to check your answers. All right, the square root of 35, you're looking for the border. So you go back here and you're looking for 35. It's in between 25 and 36. Really close to 36, I might add. So it should be its square root close to about 6. So did you answer about 6? It's just smaller than 6. And notice I'm using my approximation sign by wiggling the equals. Okay, how about 170? Let's go look at our perfect square trail. Oh, okay. It's got to be bigger than 169, smaller than 196. And again, it's only 1 bigger than 169, but it's 16 away from 196. You can do that by subtracting. So it's only 1 away from 169, so it is really close to 13. Slightly bigger than 13, so I'm going to put about 13 because it's asking me for the nearest integer. Now, 44.8, I'm going to call it, it's about 45. Let's just go see if we can figure out where 45 would be, 44.8, 45. So do you see it would be in between here? 448, is not a perfect square like we did in the last video. So we're going to make that be about 45, and it's going to be in between 36 and 49. Now this one's not as close as the last two. 49 minus 45 is about 4, and 45 minus 36 is about 9. Remember, because I estimated that to be 45. So it is a bit closer to 49. So the square root of 49 would make it 7. So it should be about 7. And that's how we estimate square roots, to the whole number or to the integer if we had a negative out in front. Okay, so what changed here on page 82, example 2? And I'm giving you a big clue by a red circle on the screen. Do you see it? Yeah, no longer are we talking about estimating square roots by dropping the 3 in there. We're looking for a cubed root. We're looking for identical triplets. So we're not going to look at our perfect square trail. Everybody hear that? We're now going to look at that list that we made up the other day. And here it is. Okay, here are your perfect cubes. So now we have to look here to see, where does 320 fall in the perfect cubes? And I come down looking for 320. Oh, he's in between 216 and 343. So everybody see that? So he'd be right in here. So his cubed root is in between 6 and 7. And notice that's kind of what they're drawing right here. Now, 343 minus 320 is about 23 right here. It is 23, actually, not about. But if I take 320 minus 216, that's 104. So this cubed root of 320 is closer to the 343. So if we're asking about the nearest integer, it's closer to the 7. It would be less. It's smaller, but it's closer to the 7 than the 6. Keep this list. Know that it's here if you need to rewind the video. Sorry. All right, so now we're going to do the cubed root of 62, 25, and 129.6, which is about 130. So you're going to come back to here and see if you can figure out, where is the approximation for those perfect cubed roots. I'm going to leave it here, ask you to pause the video, and see what you can do with D, E, and F. All right, let's check out 62 on that perfect cubes. 62 is in between 27 and 64, really close to 64, a lot closer to 64, my friends, than 27. So his cubed root is closer to 4. It's a little bit less, to be honest, than 4. Did you put about 4? Now, the number one mistake here is to go look at the perfect square trail. Remember, when you've got that little 3 in there, we're looking for a cubed root, not a square root. Okay, now we're looking for 25. Very common mistake would be to slap a 5 down here. It's not a square root. So we're going to go look at our cubed root list for 25. He's going to be in between 8 and 27. And again, much closer to the 27, slightly smaller than the 27 compared to the 8. So it's got to be closer to 3. And if, a little bit less, but we just need to make it to the nearest integer like before. Now I see this decimal and I go back and I look for 1296. Notice it's not going to help me at all to be a perfect cubed, even with a decimal or anything. So here I'm going to say, this is about 130. Let me just think it's about 130. And let's go back and see if we can find where 130. Okay, so 130 would fit in between the 125 and the 216. 130 is 5 bigger than 125, but it is a lot further away from 216. So the cubed root would be closer to the cubed root of 125, just a little bit bigger, but I'm going to call it I'm going to estimate it at about 5. And that's how we can estimate cubed roots. So for the last thing today, just to kind of give you an idea, I am going to talk about the fact that you could go further. And I'm going to make it this year, you will know what to do, as I'm going to explain in a second. You'll have kind of a multiple choice where you've got to pick the best answer now. And no longer am I asking you to go to the whole number or the integer. I'm asking for a tenth. I want 1 decimal place on there. So if we were to start with the square root of 54, and we go back to our perfect square trail, guys, we're back on square roots here. I'm not going to do cubed roots to the 10th, just square roots, okay? So I'm going to go back to the perfect square trail, and I'm going to realize that 54 sits in between 49 and 64. Those are my perfect squares. The square root of 49 is 7. The square root of 64 is 8, and I get that off of the multiplication chart. Now 54 minus 49, it's 5 away here, but 64 minus 54, it's 10 away here. Notice it's closer to the 7. So if this was to ask for the whole number, we would be done by saying 7 like we did before. We want to take it one step further, however, and we want to answer this question. Which of these numbers is the square root of 54 closest to? And notice now I've put a decimal place on there. Okay, so we got to pick one of these 5. And I brought that number line over so we can see what we were just talking about. We know it's really close to 7. We know it's slightly bigger than 7. So let me come over here and grab my pen. And let's just put sort of a number or a dot, a point on the number line where these numbers are. 6.9 is smaller than 7, so that would be kind of where 6.9 is. 8.1 is bigger than 8, so that's where 8.1 might be. And both of those are kind of ridiculous answers because we know that the square root of 54 has to be bigger than the square root of 49 and less than the square root of 64. So both of these right now we could kind of cross out, and we'll do that in a second. So let's talk about 7.5, which would be halfway. So I'm just going to try to eyeball it. Is that about halfway? That's about where 7.5 would be. And notice that the square root of 54 would be below the halfway mark. 7.8 is going to be bigger than that. So it's somewhere here. And pretty quickly, I can kind of figure out that the 7.3 is going to be the one that's going to be the closest to the square root of 54. Let me come back and just mention again why. I'm just going to get a line so we can kind of cross out here. So the 6.9 was no good because it was less than 7. And the 8.1 was no good because it's bigger than 8, and we know that our number has to be in between. We then went and looked at the halfway mark, 7.5, and we took him out because 54 is only 5 away from 49, 10 away from 64. It's less than the halfway mark, which then made this one, which is even further to the right on the number line. And boom, that leaves us with the answer that we are looking for, which in this case would be about 7.3. So let's circle him and call him the winner. So when we have a multiple choice like that, usually some of the answers are kind of ridiculous, and we can narrow it down by thinking where the numbers are positioned on the number line. So the best estimate would be 7.3. Now, somebody out there is saying, yeah, but Mrs. Woodruff, what if you had like a 7.4 or 7.2? Like, how would I know if the numbers were closer together? So I'm just going to mention this next thing. Think of it kind of like when we did the repeating decimal, and I said, I just wanted to expose you to it, but I won't test you on this. You would have to take, if you wanted it even closer and you were like, oh, is it 7.3 or say 7.4 had been up here, you then kind of have to do a little bit of math by hand if you don't have a calculator. You would take that 7.3 and you'd square it. Remember that the square root is the opposite of squaring. So you'd multiply 7.3 times itself, which I'll show you in a second. And then you decide, how close are you? And then if 7.4 was a choice, you'd have to do the same thing. Now, I'm just going to show this to you this one time. Okay, everybody? So I would take the 7.3 and I multiply it by itself. 3 times 3 is 9. 3 times 7 is 21. I'm going to move over to the 7. Don't forget to put a 0 here and move over as well. 7 times 3 is 21. Hold the 2. 7 times 7 is 49, 50, 51. Add down, right? And then see 1 decimal place to the right here, 1 decimal there. There's 2. So you start at the end and move it in, and you see you have 43.29. See how you're too small? You wanted 54. So if you take 54 minus that 53.29, you're 0.71 too small. Now, if you multiply 7.4 the same way we just did, notice you're too big this time by 0.76. Man, these guys are close, look. But who's closer? 7.3 by a little bit. So 7.3 is a really good estimate for the square root of 54. It's better than just saying 7. This is just getting even, a little bit more precise looking at that. So let's go back and try another one. We're not going to go down. I'll give you choices again that will help you to kind of be a little more obvious. And let's just say we had 41.3. So we're going to go back to our perfect square trail and find which 2 perfect squares it fits in between. So the first perfect square that's less than 41.3 would be 6 squared, or 36. Square root of 36 will be 6. So down here, we know the lower bound, no way is the square root of 41.3 less than 6. Now, the next perfect square bigger than that would be 7 squared, which is 49. Square root of 49 is 7. So we know that our square root of 41.3 has to be in between. So I took 49 minus 41.3, and it's 8.7 away here. And 41.3 minus 36, it's 5.3 here. So it's about 8-ish away here, about 5-ish there. It's closer to the 6. So if I was asking for the whole number, we'd say, it's about 6. That's where we kind of started, That's where we started today, right? So we know it's in between 6 and 7, but it is closer to 6. Okay. Now I'm going to go to the next one and I'm going to give you choices. I'm going to put a decimal on the square root of 41.3 and we're going to make a choice to the 10th. Right now we say it's slightly bigger than 6. Is everybody okay with that? What if these are your 5 choices? Again, let's look at where they're placed on the number line. So 5.8 less than 6, right? That's already impossible. 7.2 greater, already impossible. 6.1 would be slightly bigger. 6.8 would be slightly smaller. So who's our best choice? About 6.4. So oftentimes when you're given a multiple choice, you can kind of eliminate the unlikely ones and figure it out that way. Let's just see kind of a real world example here. Wyatt wants sort of a real world example, but Wyatt wants a fence in a square portion of the yard to make a play area for his new puppy. The area that he's going to cover is 2 square meters, and he wants to know how much fencing he wants to buy, which means he needs these 4 sides. He needs to know length of the square. When you're given the area to find the side length, you have to take the square root. So we're going to look for the square root of 2, and then we're going to find the perimeter from that. So the square root of 2 is going to be in between the square root of 1 and the square root of 4 on the perfect square trail. So the side length is somewhere between 1 and 2 meters. Closer to the 1 than the 4, so kind of less than halfway. So we're going to find the perimeter, and we're going to multiply the square root of 2, what we think it's about, times 4. And I just told you it's a little bit less than half, so I'm thinking it's about 1.4. So one side would be 1.4 meters and 1.4 meters and 1.4 meters and 1.4 meters. So 4 times 1.4 would be 5.6 meters. 4 times 4 is 16, hold the 1. 4 times 1 is 4, add that 1 back in, and you need 1 decimal place, so you roll in 1 decimal. So he's going to need 5.6 meters from Home Depot or Lowe's. Okay, one more example here. The golden rectangle is found frequently in nature, but it's also found in the nautilus shell. It's got this pattern, this symmetry that exists. And if you take the longer length of the rectangle and divide it by the shorter length, you kind of get this division statement right here. So the length of the longer side divided by the length of the shorter side is equal to 1 plus the square root of 5 divided by 2. So the longer side divided by this side, that's kind of the golden rectangle. So estimate this value. So we want to know, what is the square root of 5? Square root of 5 on the perfect square trail would be in between the square root of 4 and the square root of 9. Square root of 4 is 2. Square root of 9 is 3. So the square root of 5 is really close to 2, slightly bigger than 2, like 2.1, maybe more like 2.2. I think it's about 2.2-ish. So if I put the 2.2 in for the square root of 5, I'd have 1 plus 2.2 divided by 2. I'm going to add 1 plus 2.2, which would be 3.2. Doesn't that kind of look like 32, right? 32 divided by 2, cut 32 in half, it'd be 16, but you got to put that decimal back in, and it would be 1.6. So the estimated value would be 1.6. So the last thing, I just want to make sure your book kind of didn't cover this. They kind of expect you to know it from the last section. But remember, we had equations like this in the last section. But now, instead of having perfect squares out here, we have non-perfect squares. So what I want you to do is pause the video and go back to the square root trail and figure out about, and you can do it to the whole number here, guys, not to the 10th, about what number would x be, or numbers, I should say, would x equal here. So go back to the square root trail or look at your reference guide and figure out what x equals here and about what a equals there. Let's see how you did. Okay, so 127, you should have seen in between 121 and 144 a lot closer to the 121, so it's about 11. And remember that there are two roots here. The square root would be plus or minus 11 when we're doing those equations. You'll remember that from the last video. This is about 60. So 60 is just less than 64, bigger than 49, but it's really close, much closer to the 64. So the square root is much closer to 8. So A has got to either be a negative 8 or a positive 8-ish. It's about plus or minus 8. So that's how we estimate square roots. We're going to get a chance now to practice that in next class. Again, just keep that perfect square trail and the perfect cube reference guide handy. Not using a calculator, but it will be coming back soon, I promise. Have a great day, everybody.